we're just going to look through these notes first under that dated folder, 2022, May 12th. And yeah, that is where we are. Okay. So I'm going to go ahead and kind of start giving an overview. Basically, what we're doing is we're using the web browser to draw graphics. And the way we're going to do that is using JavaScript, which is code that's going to run in the browser. So we'll be able to write JavaScript code and then the browser will run that. This is really convenient because you don't need to like download any software or anything like that. But you will just download a file, which I'll show you how to do momentarily. And for those following along at home, yeah, you'll also be able to download this file. So in particular, what we're going to use today is a library, a JavaScript library called PTS, which is listed here at the top. So a library in terms of code is basically like a collection of pieces of code that someone else has written or we could write as well. We could create a library. And it lets us basically just reference different bits of code that someone else has written very conveniently. So this library is a graphics library. And the point is that we can write our own code, which just uses the code provided by that library. And it's usually going to be a simplified way of interacting with something, with some deeper piece of code. So a good example of a library might be like something for audio, where if you want to play a sound on your computer with some code you write, you don't want to have to like write all of the code required to like play, like vibrate your speaker on your computer. That would be a lot of work. So you use a library, which will then figure out most of that for you. And then you just call one piece of code like play sound or something. So this is the advantage of a library. This library is going to let us basically do graphics with JavaScript to a pretty sophisticated degree that would just be a lot more complex to achieve just using JavaScript alone. With like the API provided by the browser or the library provided by the browser. It's also going to make things, yeah, like somewhat easier to think about, like, but yeah, it'll be interesting. So there's this blog post in this link here. If you're interested in reading about the library, like why this person made the library the way they did. Yeah, it's in the notes. Yeah, all the links are in the notes. It's that third bullet. Yeah, so that's just if you're more interested in like why the library was made the way it is, because it's kind of a unique approach to graphics. But the person is a little bit strange, so take that with a grain of salt. But I think the library is cool. So what we need to do if we're going to build graphics in the web is we need a document. So we need to make basically a web page, but we're not going to like put it out in the World Wide Web. It's just going to be on our computer. And we can do that. We can point our browser basically to a document on our computer and it'll just load it as if it were on the internet. So that's what we're going to do first. So basically I linked the document that you need right here. This is the document from the last session though. So we're going to need to make some changes to it, which I've outlined right here. For the sake of time, I'm not going to worry too much about explaining the changes that need to be made. But the gist is basically we're going to include this library that I was talking about, the PTS library, which we're going to use, which we're going to do using this little piece of code here. And then an element of this document that I talked kind of extensively about last session, we're going to use in the same exact way. This is how we draw graphics. In JavaScript, it's called the canvas. If you want to learn more About the canvas, you can look at the last session, but it's not super important. It's just exactly what you would think. It's a canvas. It's basically a space where we can draw. That's what we're adding to our web document. And so we have to use the canvas a little bit differently with this library. And so that's what all this code is here. That's what this code is doing. So it's basically going to set up the library so that we can draw with the canvas. And then this stuff is kind of specific to the library, which I'll get into. So the first thing you want to do, if you want to follow along, you don't have to follow along, but if you want to, what you'll do is you just go up to this folder again, and you'll find this ptjs_canvas file. If you click that, you can download it by going to raw up at the top. So then it'll look like this. Once you click raw, like I clicked raw right here, and then it'll just look like this. And you can just right click this and save page as. And then for me, I'm just going to save it as .html like that. I'm just putting it in my downloads. So then it saves as an HTML file. And then what I can do is I can go to my downloads and find it. And I can drag it over to a browser tab and it'll open just like, so it'll just open just like a web page. So this way we're going to edit this file. We're going to add all of our code to this file. And then every time we make a change, we'll just reload it and then it'll show what we draw. So that's the gist. If you want to follow along, of course, you can also just watch and then do it later too. It's totally up to you. Yeah. Oh yeah, totally. Yeah, the big. Yeah, did you try clicking this at the, I may not have shown this part.
No, you did.
Yeah. Okay. Oh, it did not let you go back to that folder?
No.
You could try going just back to the repository. Oh, good. Okay, great. Awesome. Yeah, unfortunately, you can't like download it very easily, but yeah, you have to go to open the file and then you can click raw. I think that's the easiest way. Yes. And just make sure when you save it, you have to save as and then add the .html at the end, because otherwise your browser will not open it. Okay, so in the meantime, so I've got mine open. So this is where I'm going to make all my changes for our drawing right in here. Okay. So once you've got the file going, what would be a good idea is to have some kind of editor. Do you have like a text editor that you can use?
So I'm just trying to get some like basic.
Oh, totally.
It's not a day-to-day work thing.
Oh yeah, sure, yeah.
But I saw when it was free on my.
Yeah. No, that's that's great.
I know nothing.
Okay, all right. Okay. Well, this is cool because I have all of the code that we're going to use, so you can just copy paste it in. That's totally fine, and you can just see what it does. So, okay, but what you might, so on your computer, there's this program. It's called Notepad. If you press the Windows key on your keyboard, like with the little Windows sign, like the little Windows icon. Is there a key like that on there? There should be on the bottom left, your keyboard. Yep, that's it. Yep. So click that, and then it should pop up a little search. Do Do you see that?
So I just click on
Mhm.
that, or do I click on?
Oh, yeah, you just press the key. Just press the key. Yeah. And it should pop up like a little search or something. Okay, so type Notepad. Yeah, that will guide you to an application called Notepad. And you can open that file that you downloaded. You can open that inside of Notepad. It's not the best text editor for writing code, but it totally works.
Is it supposed to look like that?
Let's see. Oh, I see. You found that's like a different application. Yeah, try. Oh. Yeah, so I see what it did. It like was like, you don't have to update it. You just want.
I saw that, but I wasn't sure.
Oh, yeah, no,
It's like,
this is it.
something.
No, that's okay. Yeah, I think it's searched online. I mean, that's a really good one, by the way. Like, that one works great. But this one is very, very basic. It's not very sophisticated at all, but it'll do the job. So then just go to File at the top left. Yeah, perfect. And then you can just say Open. And then you can just open that download that you just had earlier. Or like wherever you, oh, I see, it's filtering. Just click that little drop down on the right. This one. Yeah. Click that. And then just do all files. Okay, perfect. So there it is. So that one. Yeah, go ahead and open that one. Okay, so basically this is how you're going to edit, you're going to add the code in from the notes.
Okay.
So whenever I copy paste something in, you'll just find that same place in the file, and then you'll want to save it. You can just do Control S to save, just like a Word document or something. And then in your browser, you will just reload that tab. And it should. So we'll try it out. We're about to make a
So
change.
most of it, is it okay if I watch?
Yeah. Oh no. Totally. Absolutely. Yeah. Yeah. Whatever works best for you. Yeah. But that will, like, if you want to do it later, you know exactly now how to edit and stuff. So okay. So okay.
So before we move forward, so
Uh-huh.
when I did
Mhm.
HTML and I brought it over here, this ended up for my computer, it ended up just showing up as a blank.
Yeah. Does it look like this? No, that's great. You're good to go. Yeah. We will put something in there, but yes, in due time for sure. So this part is just basically talking about this part of the notes. I'm just talking about kind of like what we need to do to use the library with this big blank white space, which is actually the canvas. So it's not super important, but I do want to talk about these three things right here. So with this library, which you can think of as just basically like, this is how we're going to approach drawing with code. So there's these three kind of concepts that this library uses for you to draw. So there's the idea of a space. So a space is like the area that we have to draw. So that's what you should think of when you see the word space. So you'll see that come up in the code. That's what that kind of means. Then you have the form. So the form, I don't think it was the best choice of word, but it makes some sense. Basically, the form is like putting everything that we've created in space onto paper with like we're drawing it basically. So whenever you see form, it means like, okay, we're going to draw the stuff we put in space. That's kind of the idea there. And then finally, there's points. So points are found in space, and then you can use the form to draw the points. And typically, we're not necessarily drawing the points, we're drawing like using the points. So we're thinking of a point. I'll talk in more detail about that in a second. I'm going to reference some colors in some of this code, and I did so last session too. If you end up reading those notes, I didn't really explain like the way color works in particular for JavaScript in the web, but also generally when you do computer graphics, the way color works is using what's called an RGB coding. So I have this link. I'm not going to spend a bunch of time talking about this, but you can read this Wikipedia page if you're interested. This is basically how computers understand color. So it's called RGB because it consists of red, green, and blue codings. And this is called an additive color model because essentially to make any other color, what you do is you take a little bit of red, a little bit of green, and a little bit of blue. And you add some varying amounts of those together, and then you get the color you want. So if we want to talk about black, for example, in RGB, the way I would describe that is by saying 0, 0, 0. So 0 red, 0 green, 0 blue. And that is black. Conversely, white would be the opposite. So it would be the max value of red, green, and blue. And that would give us white. That's basically what you need to know as far as how the color is coded. Now, the other part of this is that I'm going to be using this special type of encoding, which is just a way of representing a number. I'm not going to use digits, which would be numbers 0 to 10 or 0 through 9. This is going to be using something called hexadecimal.
Book library will be closing in 1 hour.
Thank you.
The computers will shut down in 45 minutes.
Great. No, that's okay. So hex coding is just an alternative way to represent numbers. It allows you to represent numbers 0 through 15 with 1 digit. So I don't need 2 digits to represent 10, 11, 12, 13, 14, 15. I can use just 1 digit. And the way that works is basically you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you start with the letter A. It's just kind of a weird way of representing digits, but it comes up with color all the time because you can represent a lot of color values very concisely. It's not super important, but that's just what you're going to see. You're going to see some hexadecimal coding for the colors. So just so that's not confusing, that's what that is. And of course, that's all kind of described on this Wikipedia page, so it's not too bad. Okay, the next part for context that we'll need to start understanding some of the basic examples, and hopefully don't be super intimidated by this because you can do all this stuff without knowing linear algebra. But but there's some basic ideas that are helpful to understand, which we will visualize with all these examples. So it's not a super big deal. However, if you want to like understand the background, there's these links that I provided, which do pretty well at, it's more of like an approach like from the graphics perspective. I mean, they do use a lot of math, but it's like very visual. So if you're thinking about the graphics and then reading this stuff, it's not so bad. Like it does make sense. They relate it to something you're seeing on the screen. So it makes it a bit easier. This one is really dense, this link. This is the second link, but this first one is, I think, this first one is really nice. You could probably read like just up to maybe like here, just before matrices. And that would be you'd have like a pretty good understanding of basic linear algebra. Oh, cool. Oh, you're familiar. Oh, great. Well, then that's really good. So yeah, Okay, great. Yeah, if you're familiar with vectors, then you're in a really good place. That's pretty much everything goes from there. So everything is kind of working with this concept of vectors. So just for the stream, like I said, there's a lot of information, but with limited math background, even using this library, that's kind of the nice thing about the library is it does a lot of that stuff for you. You just have to know the concept that you're looking for. So like making lines, curves, arcs, you can do all that stuff and it will handle the math underneath that. So it's really nice. You just have to know what you're trying to do. Yeah, so it abstracts this away for us, this library, and then we can make some pretty sophisticated stuff. But with some examples coupled, we can kind of go through the fundamentals because these are all things that are necessary to understand graphics. So graphics, for the most part, happen in like a 2D space or a 3D space. And so what we're doing when we're coding with graphics is we're trying to map that space and then write code that has functions or ways of programmatically like describing that space. So that's kind of what we're doing. You're basically asking the computer you're describing to the computer what this space looks like. So it's kind of a challenge. So there's some conventions around how you do that. So the first one I want to talk about, this is like the most basic aspect of linear algebra, but of graphics usually, is a point. So we need to be really clear about what a point is. A point is basically a place within some dimension. So you can have a one-dimensional point, you could have a two-dimensional, three-dimensional point, but it's very important to note that a point like isn't anything in particular, it's just a place. It's important not to think of it like it takes up some kind of space mathematically, because it does not. It's just a place, it's a position. So that's how we're going to think of it as well with this graphics library. Usually to figure out the dimension where the point lives, it's kind of implied by the description of the point. So like if I say a point at 1, 2, that would usually imply a point at x equals 1 and y equals 2. So it's a two-dimensional, a point in a two-dimensional plane. So thankfully, we can illustrate the way this works with our graphics library with this this library utility called PT. So the code, the little piece of code from the library we're going to use it's called PT, and it's a point. But just to keep in mind, this is a lot more than just a place in space. What this code does, it lets us do a bunch of things, but it's going to help us visualize a point in space. So here's what I'm going to do. I'm just going to copy this. You can, if you're in the notes, what you can do is just use this top right-hand function. But of course, if you're just following along, that's fine too. So you can copy this. And what I'm going to do is I have a text editor here called Visual Studio Code, which is really nice for getting started with. It's really, really good text editor. It's pretty friendly. And then I'm going to go right between this line 16, get form, and just above this line 20, play once, right here. So basically, I'm going to paste the code right in, and it pasted a little bit weird, but that's not a problem. So, okay, so I pasted this code in. I'm going to save it. And before I even describe what this code does, I'm just going to make sure it works. So I'm going to go back to and I'm going to close this linear algebra and other links. I'm going to go back to this page that I have saved on my computer. I'm going to reload it. And we should see the results of this code change. So basically just added this little dot. Yeah, so this is the way you can kind of conceive of a point in space. I think most people probably do when they talk about points in math and stuff. You think of like a dot or something like that. So that works pretty conveniently for us. So, okay, this is pretty convenient to be able to think of points, but like, how did we do this? What is the code that we had to write in order to get to this? So can you see that okay? Okay, great. So the first part of this, I already kind of talked about. This is just basically how we got to interact with the library. And I mentioned this idea of space, which is the canvas. I mentioned the colors. So this is BG color, background color. So this is the red digit, the green digit, and the blue digit. So it's the max value for each of those. So it's going to be white. So that's how we get the white background. And then I'm getting the form. You have to get it from the space with this library. That doesn't matter. The point is that I guess it kind of makes sense because the idea is that the form, which is like the pencil that I described, it's applied to that space. So anytime you use the form, it's referencing the space to draw in it. That's kind of the idea. Okay, but this is the meat of what we're doing graphics wise. So we're doing two things with this piece of code. Everything we're going to do in all of these examples, we're going to do inside of this little indentation here, this block called space.add. The idea is that we're adding to the space. So everything we want to add to the space, we're going to do it inside of here. I'm splitting each of the sections for the most part into two blocks, sort of. Anything you see with these dashes, these are comments. So they don't actually do anything. So this is just plain English. So everything you see here, I'm just describing kind of what's going on. Anything that's colored, though, that doesn't have these dashes, that's actual code. So the first thing that we do is we set up a point. So in code, the way we're doing this is that little PT keyword that I mentioned. This is from the library. And what I'm saying is I would like a new point at 200, 200. The reason I chose 200 is because if you look at the rest of the document, I made the canvas 600 by 600 pixels. So I just picked somewhere in there. I could change it. Exactly, yeah, exactly. So this is the X dimension, and this would be the Y dimension. So that's convention is like probably what you're used to from math class, and also that's how it's going to be done in code too. One thing I'll point out that I think maybe just speaking of convention does deviate a little bit, but is the way you do it in graphics. So from school, you're probably used to X from left to right, and then Y, you know, up and down. One thing that differentiates in graphics, so I'll reload this. So I moved the point to 400, 400. But if I change this Y dimension, let's make it 100. You'll notice probably something that isn't necessarily intuitive. So the point moved like up, even though I lowered this number. That's because in computer graphics, virtually all, I mean, yeah, pretty much every computer graphics application, like at all, Y is always 0 starting from the top. So that's just something you just got to kind of like, if you get into computer graphics and start coding with that, it just always starts from the top as 0. So that's just the only weird part, but everything else is pretty much what you'd expect. So, okay, so we made this point, but that didn't draw the point. That just set it up in the data that our code is using. So it made this variable. This variable is basically storing the structure that defines this point. So then what I want to do is I want to give the details of how to draw the point in space to this form. So all of this is from the library. I don't like know it personally. I had to like look all this stuff up as I went along. So that's totally fine if it's like, it seems very arbitrary, because it is. It's totally arbitrary. It's just the person that made the library decided that this like looked nice and they liked the way that it worked. So If it's like maybe a little surprising or confusing to read, then, you know, that makes sense. It's not necessarily intuitive, but it's the way that it works. And once you use more of it, it'll kind of follow that pattern. So the idea, whenever you use the form, you're describing the way your sort of geometry data or your spatial data should be drawn or rendered. So this first part is saying basically to fill the point, which means we're going to get this solid sort of block approach to drawing versus a stroke, which we'll see later. A stroke is basically outlining. So whenever you see fill, it means take up the full amount of the shape, and stroke is just do the outline. So that's another common thing in computer graphics. Second part here is we're describing what to fill. So this point is a function on the form that basically says, make this shape. This is not the same thing as the point we just made. The point we just made is just a piece of data. This function is basically describing drawing information. So it's telling the form to draw a point. And that point is more like what we think of, like what you would do with a pencil, like making a point. So this is not the same as, you know, making a new PT or this variable. It's just describing drawing. So the way we do that drawing is we provide three things to this method. So we say first where we want it to draw the point. So we're just going to give it the place that we created here. Then we're saying what the radius should be of the point. So like if you had a pencil, imagine like how wide the lead would be. And then lastly, we describe the shape that the point should take. So we could change this actually, make it square. Reload it. Yeah, it just makes like a nice square point. So it's just, and it would have basically a 4-pixel radius from the center, from side to side to side to side. So that's basically kind of a good entry into the library so far. So that's very basic. Like this is all the code we need to draw. So it's basically like ignoring this and this. It's not too bad. It's like it's 2 lines of code, which is pretty basic. I mean, I don't think the code is necessarily basic, but it's not too much of it at least. So, okay. Oops. All right, let's go back to the notes. So moving on to kind of like elaborating on some of the ideas from linear algebra and graphics, we could basically start to imagine that, you know, we could add another point very easily. And PTS, the library, you can add points in all kinds of different ways. There's all points in PTS, the library, have multiple dimensions that you can make use of in other ways, but they aren't necessarily going to show up. Like obviously I can't draw a 4-dimensional point, but I could if I had like other dimensions of like ways of rendering it. So like if I wanted to add color as like a dimension, then I could use the 3rd dimension of my point to represent color or something. But I can add those in, but they just won't like appear. So let's say for the 3rd dimension, I just put it at pixel 400. It's not gonna, whoops. So I'll save this and reload it, but it actually won't do anything because I didn't draw it. So I have to describe how to draw that point. So let's just copy this line. Say form, we'll stroke this time. And we'll do a different color. So notice I use the 3 zeros, so that is black. So no value for red, green, or blue. You can probably guess what this color will look like. If I do 9, 9, 9. So A is 10, and then B, C, D, E, F is 15. So it's like the most, and 0 is the lowest. So this number is in the middle. So you can think about what color this will be if it's just all in the middle. Okay, and let's make it bigger. Maybe we can do a triangle. I actually don't know. We'll find out. Okay, did you come up with the, do you know what color it will be?
No, I do remember you saying that so if you do the lowest,
Yeah.
it'll give you black, right?
Right,
And if you do the highest, it gives you white.
right,
Correct.
yeah,
Okay. I don't know, gray?
Yeah.
Okay.
yeah. Oh, where is it? Oh, maybe it doesn't like triangle. Yeah, okay, so that's another thing. So it's probably good to explain. I did not put this in the notes, but there's some tools here for debugging. If you, in your browser, it'll depend on what browser you're using. The only problem with like using web stuff is it's not so obvious when you get an error, because the way a web page works with JavaScript, it's going to run as much JavaScript as it can. And if it hits an error, it's not going to like tell you on the page in any meaningful way. It will just basically keep it kind of relegated to this, what's called this console, this developer console. You can open this by going, whatever browser you have. It should be pretty easy to find it.
It's telling you that triangle is not.
Exactly. Yeah, exactly. So I just wanted to point out, like if you're like, something's not working, check the console and you can usually find what's going on. Yeah, this library is pretty good. It's got usually pretty helpful errors, but this is coming from the library. It's telling me this. So this is nice. So now I know, okay, I can't do triangle, even though I tried. Maybe there's, I don't know. I can't think of any, maybe, I don't know. I just want to see if there's other. No, it doesn't like that. Okay. I guess I don't have a lot of options for points. That's okay. I mean, we don't really need a lot. Okay, cool. So you can see this one is stroked. So it just does that outline. So the outline is basically just outside of this radius. And then the fill is everything inside of the radius. So what we could do to kind of combine these concepts in one, what I could do is do a stroke here. And then do like, I'm gonna make up a random color. I have no idea what that will be. I guess it'll probably be, I don't know. I have no idea. So what I could do is I can stroke the same point. Is it even visible? Maybe it's not. Oh, I'm gonna close this. I don't need that. Stroke only, fill only. Oh, maybe I just have to say fill and then stroke. Let me try that. Maybe the color is not. Yeah, I don't know actually. I'm just making up. Yeah, I mean, it's kind of hard to guess them. Okay, it is working. You can just I need to make it bigger. Let's do a bigger circle. Yeah, so it's all, I mean, I know some people that can actually, let's make the stroke radius bigger so it goes outside too. Oh, whoops, I did the, oh wait, yeah, that's what I want. And I think I can specify how far out to stroke to. Yeah, okay. So this just made the stroke It's interesting that it also affected this one. I think if you use the stroke and then you change it, like subsequent strokes will then also be affected. So, I mean, there's just little things like this you just pick up as if you were to use this library. But yeah, as far as the colors go, I think I've maybe known like one person who could guess pretty well, but it's, yeah, no one does that. So like most people use this thing called a color picker. So there's one on my computer, but you can also go like on Google. If you just go to Google, yeah, so it'll just pull up this little tool. And then what you can do is it should, oh, well, it doesn't give you the little thing. It's disappointing. The little pen, the little dropper.
No, but it gives you your.
It does, yeah. That is nice. So yeah, you can see the RGB value here on the bottom left, but like on this one on my computer, like I can just put my mouse on any color. So that's like what most people do. Like if you're a developer and you like need a color, you just go hover over whatever, and then you can see these RGB values. Those are out of 255. So the 255 would be the highest. Yeah, but we're using, we don't have as many colors available because we're using only numbers up to 16. So we could use more detailed ones. And to do that, we would add 6 total digits, but I'm just keeping it simple, just with 3 digits. Okay, so that was a lot of extra detail. The last thing, though, I don't think we'll get to angles or transforms, but oh, really? Okay, cool. Okay, well, okay. Yeah, we still have a good bit of time. Okay, so we experimented with adding some more points, which was pretty cool. Maybe I can put this back down. Is that how this would work? I don't like this square. Okay, yeah, I guess that's how you do it. You just have to re-specify. Interesting. Okay, so logically, the next step, so we have a good visualization of like points in space and how to draw them. The next logical step would be conceptualizing vectors. So how can we visualize vectors and how they work with this library so that we can start to draw kind of like advanced shapes. So that's what we'll do next. And first we can kind of clarify like what a vector is in this context. So, you know, if a point is just a place in space, then a vector is basically the separation between place in space and another place in space. That means that it doesn't belong to any particular location in space. So if I have a point, like let's say this, actually, let's just do this right now. Let's just visualize this. So what I'll do to get a vector visualization is I'm going to me basically draw a line between 2 points. So what I'll do is I'll stroke the line, and I will use, do I still have my color meter? Let's actually try to use some colors that I want. Oh, this is a meter. Actually, now I want to make colors. Okay. Let's use this green. Ooh, but see, these are too high resolution. I don't have access to these colors. We'll just guess though. I don't know. It's probably like, so medium red, high green. Yep, that's fine. So kind of low, like 4, medium-ish, like 8, a little less than medium-ish, 7. We'll see if that gets even close. Maybe it will. Okay, so that's what our line color is going to be. And then now we're actually going to make the line. So the way we make the line with this library is we just imagine 2 points that we want to put the line onto. So that's pretty easy. What we do is we just use the points that we already have. So we're going to provide the first point, which we saved as a variable. And we'll provide another point, which we also saved as a variable. And that's all we have to do. So if we reload that, we get this nice line. So this we can think of as a vector. Really, we already kind of are working with vectors using these PTs, these PTS PTs, because the unique thing about these points is they have all these different properties that we can access in the code. And the reason that they can do that is because this library is built for computer graphics. So it's assuming that everything is relative to this top left corner of the space. So that's 0, 0. So basically, whenever you make a point, you noticed how I specified, 200, 200 to offset 200 across and 200 down. The library knows that I'm doing that. And it's going to assume that all of my